So we started talking about network protocols, right, in the last class. So let's continue on that topic. If you have your, make sure you have your, you want to have your textbook. We're going to refer to that a lot so we can get through this chapter. All right, you guys can see my screen right now?
Yeah.
Yes, sir.
Okay, good. So, let me just... So talking about network protocols, excuse me. Just to remind you, we started talking about kind of two types of, should I say, protocols, or two types of architectures, systems of protocols. We have the Tcp Ip architecture, and we have the other one here, the Osi model. So we can say two types of models. The Tcp Ip model has 4 layers, right? So you got to kind of remember that: application, transport, internetwork, and network access. The Osi model has a more expanded version, and that is 7 layers. Very important to just be able to distinguish. One of it is 4, and one of it is 7. The 7 is the Osi model. The TCP IP is like the more, shall I say, maybe the more popular model. And if you compare both of them, we go to this screen here. To the left, you have the Osi model. To the left, you have the TCP IP model to the right. Now you can see that when you compare the, I guess, the names of the layers, on the TCP IP model, you have the application layer. The opposite side for the Osi model, you have application, presentation, session. So the Osi model is more, should I say, a more expanded set of protocols. You go down to the transport layer, same thing on both sides. You go to the next layer, network, internet. So this is like the internet, which is what you have here, internet work. So this here should be internet work layer, and same thing with here, network layer. Now when you get to the bottom, the network access layer, on the Osi model, you have the link and physical. Physical, this is a Y here, not an I. The physical layer is where you have your cables, fiber optic, copper, you have your electrical signals and stuff like that, all happening at the physical layer and generally at the network layer. So when your data, let's kind of break it down, you know, what happens on the different layers here. So we refer to the book on page 225, chapter 5, 226 rather, chapter 5. Now it tells us right there that data, or should we say a unit of information, right, is simply called data when it is at the application layer. So when you're dealing with things that we talked about already, we're going to a little bit more, you know, just a little bit more today. You're dealing with FTP, file transfer protocol, HTTP, HTTPS, things like that. Your unit of information is the name, or is referred to as data on the application layer, right? Now you come down, so your unit of information kind of comes down the layers. It starts from application, goes down to transport, goes down to the internet work, goes down and out of your network through the network access layer. Same thing on the Osi model, right? It's got to start from the application layer, it goes next to presentation, then to session, transport, network, link, and physical, and out, you know, out of your network to on its way to its destination. I'm going to look at all these layers and what they are all about. But let's look at the data. So the unit of information is referred to as data on the application layer, right? It's simply called data. Now, when you come down to the transport layer here, there are two protocols that work on the transport layer: the TCP protocol and the UDP protocol. Now, if you look at page 226, the second section there, second paragraph, I think, right below the figure 3.5.3, it says the unit of information the transport layer works with is called a segment. So there are two protocols there. That data is now called a segment when it is using TCP, right? When it is using the TCP protocol, the TCP protocol, and again, your TCP protocol, from what we saw, is transmission control protocol. So when it's using the TCP option, the data is referred to as a segment. Now, when it's using the UDP option, the data is referred to as what? Yeah, I need a response from somebody. I need a response. Are you guys looking at the book? When your data is on the transport layer, page 226, it's using TCP, it's called a segment. When it's using UDP, it's called a what?
Datagram.
It's called a datagram, right? Datagram. That's the name of your data now. Data is not always called data all the time. I know we use that all the time, just say data, data, data. But data is only called data when it's at the application layer. When you get to the transport layer, it's referred to as a segment or a datagram. Now you keep coming down the line. When it gets to the network layer, it is now referred to as a packet. It is a packet because it now contains an IP address. When it gets down to the other layer, which is the network access or the link and physical layers, it's now referred to as a frame. So you got to be very aware of the names of your data. You're going to see a lot of this in your assignment. The data changes its name. Okay? All right, let's go into a little bit more specifics. We looked at some of the application layer protocols, but let's see a little bit more here. So we're going to flip in the book and go to page 231. So we looked at HTTP already. HTTP is what you use when you browse you go into a browser, right? We talked about that. We talked about email protocols. Let's talk about the remote desktop protocol on page 232. That is also an application layer, right? Applications deal with what? We talked about it already, with servers and clients. So you have a client, your computer is the client, and you're trying to access a resource, a server. So there's always a server-client relationship when you talk about the application layer, all right? All right, so remote desktop protocol is one of those protocols that functions at the application layer. Now you have the remote desktop protocol on your computer, RDP. This is your remote desktop connection used on a Windows computer. If you're in an office, right? If you're in an office physically, yep, you're in an office, you got, co-workers in your office, and you're the IT person, you don't always have to go physically to another computer to troubleshoot the computer, right? You have your remote desktop connection on your computer, you punch in the IP address right here, and it connects you to that computer, just like on Zoom, the way you're seeing my screen right now. That's how it happens in an office setting too. If you wanted to troubleshoot my computer, you will use this remote desktop connection and you will log into that computer, right? Just like I think I've shown you guys this before. If I want to log into my computer that is at UMass Boston, I will go in through PuTTY. The PuTTY is already, this PuTTY program is already set up with all the connections. So I'm just going to click away. I put in my, actually, I think my password might have expired. I got some info today about that, but let me see if it, let me just see what happens. Oh, okay, well, it looks like it's fine. All right, so I'm going to pull up the RDP, or, you know, this RDC here. I hit connect. Okay, so I'm going to connect because I think my password is expired. I don't have time to do it right now. It says I should enter a new password. Well, I can't do that right now because I don't have time for it. So, but using that RD remote desktop connection on your computer, right, you're able to connect to other computers in your network, right, in your network. So IT people use this a lot where you want to troubleshoot. And, you know, we have more experience in the last 1 year because there's a lot of remote work. Before this became so popular, IT people would use this tool to connect to the computer, you know, from home to the office. So you guys have a lot of experience doing that right now, thanks to COVID-19, right? So what it says right there on page 232, that it is a Windows interface, right, that helps you connect to another computer and control that computer remotely. Now the port, right, we talk about ports. The port, it says RDP uses TCP port 3389. 3389 is the port on which it works. So, you know, so some of this more popular, should I say more popular protocols, you need to also know what the port numbers are, right? A quick Google search will say port numbers, right? There's some that are more popular. We have a lot, but, you know, we don't look at everything. So let's look at here. We call them the more popular ports. So if I go to this, okay, right here. So the common network ports you should know, or yeah, common ports. So if I scroll down this search, you can see right here. Where is it? All right, so here's a good list of the more common ports that you might come across. You have your file transfer protocol right here on port 20 and 21 actually. Secure shell. When I pulled up that PuTTY, you know, PuTTY was all set up. This PuTTY program runs on a SSH. SSH protocol is a secure shell, right? When you're doing remote connections, SSH is used. So that SSH there runs on port 22. 22. All right. We've got Telnet. So right here, SMTP. If you look in your, excuse me, SMTP, if you look in your book on, where's SMTP here? On page 232, SMTP is right there. Now, SMTP, what's the job of SMTP? SMTP is the standard protocol for sending emails. So we got two protocols there, SMTP and POP3. SMTP is used to send, right, to send emails. And how about to receive emails? Which protocol is to receive? Anthony?
Would that be port 25?
What's the name of the protocol used to receive?
Simple mail transfer protocol?
I said to you guys, you need to be looking in your book, right?
Oh, yeah.
Right there, it says it right there on page 231 and 232. On page 232, it says to send is SMTP. On page 231, it says to receive is what? What's the name of the protocol?
Post Office Protocol version 3.
POP3, exactly.
Yeah.
That's it right here. You see this right here, Anthony? Port 110.
Yeah,
POP3 used by email clients to retrieve, download, receive, same thing, right? So that's on port 110. We talked about the domain name system already. that's on port 53. HTTP runs on port 80. Let's see. So those are like the most common ports. You have So let's say the top I don't know 10 you have here or so are the most common, right? Protocols that you want to know about. Dhcp is not mentioned here, but Dhcp is also a pretty important protocol. We talked about that. That is how you get your IP address, right? Dhcp is used to get your IP address when you're in a network. Okay, now let's talk about that Dhcp a little bit here, because it's important to understand that. So on page 233, right, we see that information about Dynamic Host Configuration Protocol, DHCP. Okay, now let me explain something here. So when you're talking about DHCP, you're talking about right here on your computer, you go to your CMD, ipconfig/all. And you can see, if you look under your actual connection there, my connection is, I think it's this one right here. You can see that DHCP is enabled. Now, DHCP is Dynamic Host Configuration Protocol. It means that I am in a network. So your network can be at home, it can be at school, it can be at a restaurant, it can be, at a friend's house. Basically, wherever you get internet, right? That's your network. So that network is going to provide you with an IP address. Okay? Now, here's a question for you guys. I asked the other class. So let's say you have two computers, right? Two standalone computers. All right, let's say, let me get to computers here. Let me see if I can find two connected computers here. Just a picture. Come on, give me something here. Let's say connected. All right, let's try this here. All right, so let's use this picture. This works. Let's use this picture here. All right, so you have two computers exactly like this. Now, you take an internet cable, right? You take just a single internet cable and you connect these two computers, directly, like the actual, computers directly. So the question is, remember what we said about when you're in a network? You have internet, so you're wired up or you're using wireless or whatever it is. But right now there is no network here. You just bring these computers out of the box, you set them up, they're working, but there's no internet. All you do is you take a cable and you connect these two computers directly together. That's just all you do. The question is this: can those two computers communicate with each other just using a cable to directly connect them? Michael?
Yes, I think you can. Actually, I'm sure I know you can.
So no internet, nothing. Just take one single cable, hook up these two computers, and you feel like they can communicate with each other, right?
Yeah, probably in specific ways. There might be some restrictions because you don't have a DHCP and stuff like that, but they can communicate with each other. Yes.
Okay, Brandon, what do you think? Two computers directly connected together, can they communicate?
I believe so.
Okay. One more person. Harvey, what do you think?
I think so.
You're kind of like 50-50. So what's the other half?
No, I'm just saying I'm pretty sure I am. I think so.
Okay. Well, when a cable, right? You know, network is not all about. It's not all about internet. If you take that cable, right, connected to one computer, and you plug it into like a router, then you have internet. But now you don't really need the internet in this case here. You just want to directly communicate with another computer. No internet involved. So you take that same cable, instead of plugging it into a router at home, for example, just plug it directly into another computer, one-to-one, what we call peer-to-peer. Right? You have as much communications between those two computers. Now here's another question for you. Computers need IP addresses to work. So if you're saying that these two computers can certainly communicate, well, they need IP addresses. Without IP addresses, no two computers can ever communicate. So the question is, where is the IP address going to come from? Now, you're not part of a network. If you were, then you could get an IP address from your DHCP. Now there is no network. It's just two computers only, right? How are you going to get an IP address to allow you to communicate? Harvey, let me go back to you.
What was the, sorry, what was the question?
What's the last thing you heard me say?
I heard you mention that networking was not only just connecting to the router, because that's just like Wi-Fi and stuff.
How are these two computers going to communicate? They need IP addresses. If you're connected to your network, okay, then you know you're connected to DHCP, and DHCP is going to allow you to get an IP address. Now there is no DHCP involved, no DHCP, just two computers connected directly together. How are you going to get an IP address for each computer so they can both talk? Do you hear it now?
Yes.
So
I'm not too sure, but can I guess?
you guess what?
I think possibly say these two computers most likely have like network cards, right? Or network adapters, I mean.
Absolutely.
So they would possibly connect some way through those components.
Yeah, the question is one address, an IP address is required, but there's no such address coming now from DHCP because there's no DHCP. Let me go to Michael. Michael, what do you think? Because you guys said, all right, yeah, it can communicate, which is true. How do you get an IP address for each of these guys?
It's been a while since I did it. I did it when I was like 13 for very dumb reasons, but I think it was something to do with configuring your network adapters. I think you'd have to manually assign an IP to like each NIC.
Okay, well, let me help you guys out. So flipping your book to the next page on page 235. On page 235, like in the middle section there, you see a name of or an acronym, APIPA, right? APIPA is automatic private IP addressing. Now, Michael, can you read what it says there?
Sure thing. These special address. Oh wait, you want me to start from the top?
Yeah. No,
sure.
start from right there where you are.
Okay. These special addresses are reserved for automatic private IP addressing, or APIPA. An address in the APIPA range is assigned automatically to an APIPA-enabled computer when an IP address is requested via DHCP, but no DHCP server responds to the request. Using APIPA rather than a DHCP server to assign addresses is recommended only for small networks that aren't attached to the internet because APIPA addresses can't be routed.
All right, makes some little sense.
It does.
So your Nic Card, Harvey just talked about your Nic Card right now. Your Nic Card is designed, right? Is designed to automatically self-generate an IP addresses. I mean, an IP address when there is a connection to another computer. It will those two computers, once they sense a connection, they will self-generate IP addresses when there is no DHCP server present. Remember, when we go to our control panel and you go to your network, which is right here. So in this Ethernet properties, if you go down to your network Internet Protocol here and go to properties, you see that automatically it says obtain an IP address automatically. So your computer, you don't have to worry about it. It's always going to get an IP address all the time. But right now, because of this demonstration we're working on, this is not going to work because you're not connected to a DHCP. So there's no IP address coming. So this is not going to work because there's no network involved. It's just two computers directly. So what happens? These two computers, once they sense a connection, with the Ethernet cable, they will self-generate IP addresses. Those IP addresses are for computers that are not connected, basically not connected to the internet. There is no DHCP, and it says right there that when there's no DHCP, a PIPA kicks in and provides IP addresses for both computers. So if you want to create a more secure network, so to speak, in a sense, you can connect so many computers together, not to an external router, but internally. You can have as much communication as you want, and you know absolutely that there's no interference, so to speak, from the internet. So it's another way to keep a secure network. Of course, you're not going to be able to go outside to the internet, but then if you don't need to go to the internet, your internal network can be kept secure. All right, so that's something I want to mention there. Okay. All right, let's move on in the book and go to. We talked about DNS. DNS is on page 237. That's how. Now, when you look at page 237, it's called a DNS hierarchical tree structure, right? Now, when you look at a domain name, so a domain name is what we refer to. I'll come back to this information up top for 1 second. A domain name. Cindy, what's an example of a domain name? What?
HTTPS.
What's the example of a domain name? Just give me a domain name. Okay. Give me a website name.
Oh, Google.
Google what?
Google.com.
That's the same thing as a domain name. Sounds like a fancy, oh, that's what you mean? Well, it's called a domain name. If you're in an IT setting, it's called a domain name, right? We always call it a website address. Okay? So that's one. You got umb.edu. You've got, Harvard.edu. You've got, all kinds of domain names out there. So it can be a .org, .org, .edu. Those are all domain names, right? The website name is generally the domain name. All right. So when you talk about domain names, right? There is a kind of, how do we say it now? A structure to how you lay out the name. So when you look at the page 237, because you're going to see this in your assignments. So this part here that says .com or .edu, .edu, .com, .org, the .org, in that tree structure, right, that part is referred to as the what?
Sorry.
Did you hear the question, Dennis?
No, I didn't. Could you repeat it again,
This
please?
this part is referred to as the what? The .org,
Domain.
.com, .edu.
Domain. The domain.
Dennis, are you hearing anything I'm saying at all? Page 237, there is a tree structure on that page. Are you looking at it?
The hierarchy.
Yes. You see the line that says .com, .org, .edu, .gov? Exactly. You need to see these things because when you do your assignment, you're going to just wonder, where's all this information from? Right? So when you look at a domain name is usually not just the Google or UMB or Harvard. It's kind of like the whole thing. It's called an FQDN. Right there, fully qualified domain name, like the whole thing. In fact, you've got to include the www, right? It's part of it, www. Okay, the www, right? What is the name of that? What's that referred to, Edwin?
Yeah. That's the host level.
Say that again?
The host.
The host level. See, these are all technical things, technical names, right? You just got to know it. Know it as per when you're doing an assignment, right? You might be at an internship and somebody says, let me try you out here. Do you know what this part is called, in the domain, in the fully qualified domain name? Well, you got to sound smart and say, oh, I did that in my class. That is called the host level, or that is called the top level, or the second level, right? Depending on how the website is listed. So here, this is the host level. This here, the Google or UMB or Harvard is referred to as the what? That's the second level. So top level, second level, then you have a subdomain, you have a host level. FQDN, fully qualified domain name. So there you go with that. That's under the domain name system. And that's how websites, browsers are able to locate websites, okay? All right, let's move on.
I have a question.
Sure, go ahead.
So how would you put in the subdomain level? Like where would it go in that?
All right, so subdomain will be if you have a slash. So let's say you have a, let me be absolutely sure about that. So sometimes you have a UMB, like you have a UMB, let's say bookstore, right? It goes right in there. So you might see something like that, where you have a ... umb.bookstore.edu. That's a subdomain. That's a subdomain. Bookstore there will be your subdomain. So you see the way it's listed in the book. So you have www, right? Then you have your top level. So we cannot start from the top actually, right? We start from the top. That's your top level.com. You have your second level, the Microsoft or Cengage. You have the subdomain level, and then you have your host level. So it's kind of like reversed from the back, sort of like from the back, going from the right to the left. Okay, let me see if it's kind of mentioned there about the subdomains again. So on page 238, let me be sure I have that correct. On page 238, it says, the subdomain level is optional and can consist of several names. Dennis, did you see that? Several names separated by a period. Make sense?
I see that, yeah.
So it says, for example, www.books.tomshow.com is the top level domain, second level domain, subdomain, blah, blah, blah. All right, you see that?
Yeah.
Yeah, so I think we're right about that. Okay. So, so just sometimes you just got to know this stuff because, well, I got to answer questions in an assignment. Well, I got to know where it is in the book, and I got to know what it, so, at the end of the day, you can solve the questions that you have in the assignment. All right. So that's a good question there.
Might I just ask
Okay.
one more question directly related to
Sure,
that?
sure.
Say
Sure.
at the umb.bookstore.edu, if you put a /checkout at the end of that, is that just considered a page within that section of that? I guess I'm not sure what I'm trying to say, but
Well,
that
I
subdomain level?
think I know what you're trying to say.
Yeah.
So what you're trying to say is, when you have a website like umb.edu/checkout. Now, this doesn't apply to the FQDN, but in reality, what it means is this /checkout is a folder on that website that contains some files. That's just what it means.
Okay.
So, sort of a subdomain is a little bit different from a folder. In fact, a subdomain can be like a, should I say, I'm struggling with the best way to explain this.
Yeah, no,
Let me go back. Let's go back. Yeah. I am struggling with how to explain the subdomain / differentiated from the folder. But let's do something here. All right. So it says right there, back in page 238. The second level contains the name of the institution. The subdomain is optional and can be several names separated by a period. An example is a department. So you see that a department, right, or a branch of an organization. So if UMB had, like, I don't know, maybe had a branch in Quincy College. In Quincy or in Charlestown, or had part of their branches, so to speak, maybe somewhere, who knows, somewhere in Worcester or something, right? Then they might have right here, they might say, maybe Quincy, right? So that will, let's take this out for 1 second. So what did I just do? All right, so this will represent this is like the main, it's like the main campus, and then this is like this is a branch of the campus, right? Now, let's say that there was a job fair that was going to happen, right? A job fair, like a one-off event. So in this folders, now in this domain, we're going to create one folder called job fair. Now, in that job fair folder on the website, we're going to place all our files and all our, website files. Basically, our website is going to be there. Now, of course, we might have a lot of different programs. So you might have a program for job fair. You might have something about, who knows, maybe COVID-19, right? COVID-19 help. So if you type this address here, it's going to take you to the information about COVID-19, right? But here, there's a difference here. Look at this. So if we take out the Quincy, so if you are the Quincy branch, you will need to use this address because, you're going to go through UMB and get to Quincy and then get to your COVID-19 information. If you are at UMB, just go to umb.edu. So it's like a different address. Yeah. You understand? It's like a different address.
I get it. So it's basically, it's like if that whatever that location is, the folder is that either it's there or it's not. It's
yes, exactly.
Yeah, I got
so you're going to UMB as the main campus, and then the branch of the campus is Quincy. So that's the path to your files.
Okay.
So I don't know if I made it better or worse for you.
Oh yeah, no, that makes complete sense. I got it.
Okay. It's kind of like saying, well, my address is 110 Main Street, apartment. Sometimes you might have something like, I don't know, block 1, apartment 5. Some really long address. So you get to that address, and then you have to go to a particular building in that address. And you got to go to a particular apartment. So it's got to be very specific. You understand? Because sometimes you give somebody your address, and they're like, is there an apartment 1, 2, 3, or 5? So it's the path to where the files can be found, right?
Oh, yeah.
All right. So that's a great question. All right, let's move on here. Okay, page 242. Now this stuff might blow your minds, guys. Just write it down and just store it for your assignment on your midterm. But I just got to say, because I want you guys to be aware of it. You may not have like the 100% knowledge, but just be aware of it. So page 242. All right. Now, when you want to look for a website, sometimes websites have like nicknames we give them, right? So what are the different names that people might refer to as Facebook? Do they always say Facebook? Are you there?
Yeah, I'm here.
Okay, so when you want to, let's say you want to do a search for Facebook, do you always do Facebook? Is there something else you can write to just say it's Facebook, or the way you talk about Facebook? You know what I mean?
Facebook.
What else can we, what else? Do you say like FB, for example?
Yeah, FB. Yeah.
Okay, something like that, right?
Yeah.
All right, so now things like that, right? When a website has potentially many names, for example, UMass Boston can be UMB, can be UMass, right? Can be UMass, can be University, right, of Boston. So if we did a search for UMB, for example, UMB, just a search, right? The first thing that comes up is University of Massachusetts Boston, right? So we just did UMB. If you do UMass, let's try UMass. Let's put UMass in there. It's going to say, okay, well, the closest is, well, it gives you University of Massachusetts Boston, all right? So you can refer to all this as nicknames. Nicknames. You guys know what a nickname is, right? A nickname. Jessica, do you have a nickname?
Yeah, I do.
Let me guess. Jess.
Yeah.
Okay, is that some other name that's like it's just known by a couple of people, right?
Mm-hmm.
All right. So a nickname, it's another name for for you. All right. Now, if you go to page 242 and look at that table, and you go down to where it says canonical name, right? Canonical name. So you see that C name or canonical name, it says a record. So on a website or on a domain, when you go register a domain, register a website, on the back end, you're going to see all this information. Some of that information includes a canonical name. What does it say? Jessica, let me stay with you. What does it say there, like the first line about canonical name? Jessica, can you read that part? Where's Jessica all of a sudden? All right, Jojo, you want to do that?
Which part is it again?
Page 242, canonical name.
Like the table that's there?
What?
Oh, canonical name. Sorry, I didn't see where it was.
Yeah, just go
right?
down 1, 2, 3, 4, 5. 5 steps down.
A record containing an alias for another record that enables you to refer to the same resource with different names, yet maintain only one host record. For example...
Okay, that's it. So an alias, right? Jojo, that's kind of same thing as a nickname, right? Am I right? An alias, a nickname?
Yeah.
All right. So that concept, this is important. You're going to see a couple of questions. That concept of when you can use multiple nicknames or aliases for a particular website or domain is referred to as canonical name or CNAME. This is like on the back end. One day, when you go set up a website for yourself or for your company, or you go into the business yourself or website development or whatever it is, or setting up domains, as part of IT, you may come across this kind of information. I mean, I know I did as an IT professional. I had to set up the domain for my company, and I came across CNAME, and they said, fill out your CNAMEs on this line. And I'm like, what is that? What is that? So you got to come up with all the different ways your company can be referred to, and you have to store that record or those records. Because if we type in UMass, if UMass is not a known canonical name, you're not going to find anything that has to do with University of Massachusetts Boston. If you type UMB, so all those nicknames or aliases, right, are canonical names that are attached to University of Massachusetts Boston. Okay? All right, let's move on to, so this is, a lot of this stuff here is about the application layer. Let's go to the transport layer, because we've got to try to push forward a little bit here. So on page 247, it tells us there that the transport layer has two protocols, right? The transmission control protocol and the user datagram protocol. And that's back here. So let me flip to that page here in the transport layer. Right here. All right. So it has two protocols called the Tcp Protocol and the Udp Protocol. All right. Now, very important, to distinguish these two protocols, right? You have the characteristics of TCP. It says connection-oriented and designed for reliable transfer of information in complex internetworks. Connection-oriented. Now, here's I guess the best example, or a very good example that we used. That is, Jojo, let me go back to you. Let's see what we mean by connection-oriented, right? And connectionless. So, let's see. If you're going to send you order a package, right? Or you want to send a package to somebody, or an application for some kind of scholarship, right, Jojo? When you go to decide, how do I want to send this? This is really important. It needs to get there in exactly 2 days, and I want to be able to track it. So what would you do? How would you send it, Jojo?
Well, it would have to either be like, depending on what type of like application or something, like,
yeah,
either like through mail or email.
No, you have to. It's an actual. I mean, it's a kind of a form. You got to fill out all this form, sign. Sign the signature. And you have to mail it to them, like actual mail. It's not email. You have to send, so many documents to this guys for this scholarship, right? So how are you going to send it? What's the best way when you want to be absolutely sure it's going to get there and you want to be able to track it? You know what I mean?
I'm not really sure. I mean, the only way, like, I feel like there's like a specific, like, faster way to mail things, but I'm not sure if there's like a different post office thing or.
Okay, so now why do we use FedEx, for example, and things like FedEx and UPS? When you use FedEx and UPS, or you go to the post office and say, I want to register this mail, right? You're going to fill out a couple forms, you pay some extra money, they give you a tracking number and things like that. Same thing. Okay, think about it as, Jojo, have you ordered stuff from Amazon?
Yeah, I order stuff all the time.
Yeah, like you ordered this morning, all the time?
I actually ordered the other day.
Oh, really? All right. Now, what happens when you order? there's a tracking number, right?
Yes.
Okay, there's a tracking number. Okay, now that tracking number, it provides a connection between you and that, whatever it is you ordered. There's a connection there. Or at every point in time, you can tell where that order is. You can tell if it's on its way, if it's going to be here in a few hours, in a few days. You can. There's a lot of information you have about that order. If there's a problem with the order, you can figure it out and return it. And there's a lot of tracking information. When we talk about the transmission control protocol, in a sense, it works like that. There's some data that have to be transferred in a more, should I say, trackable way. There's going to be a connection oriented, right? When the connection has to be reliably transferred, right? Now, if you have a regular letter, you write a letter, or you have a birthday card and you want to send it to somebody, okay? Dennis, back to you. If you had a birthday card to send to somebody, would you take it to FedEx and register the birthday card?
Yes.
If you had a birthday card, you will take it you will go to FedEx and you will pay money and register the birthday card to be delivered like ASAP?
I mean, well, I guess it depends on like how urgent it is.
An urgent birthday? Have you ever heard of an urgent birthday card?
Like what if you were doing it like the day before?
Oh man, what it means is you didn't really care about that birthday in the first place. You just totally forgot it.
I guess so.
Right?
Yeah.
It's last minute. But let's say just a regular birthday, you will just put in the regular mail, right?
Yeah, of course. Why would I pay more?
Exactly. Just put in the regular mail. It will get there. Just send it like a week in advance. It will get there. That is how the UDP works. UDP sort of works. It's called connectionless. Now, when you put that birthday card, right, in that letter box, you have no connection to it. You don't know what day it was picked up. You don't know when it was delivered. You don't even know if it was delivered at all. Maybe you find out 3 months later, your friend says, "Hey, Dennis, what's going on?" I mean, you mean, I thought we were friends. You're like, "What do you mean?" You didn't even send me anything on my birthday. Oh, I did. No, you didn't. Oh, I did. Then you find out that you never got there in the first place, right?
Right.
Well, that's kind of like how connectionless work with UDP. So when you see a question like, what is the reliable transfer protocol? A reliable transfer protocol on the transport layer is the TCP protocol, right? Now, when the message has to go, and we don't really care when it's going to get there, hopefully, blah, 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 it may or it may not. If it doesn't get there, we'll just resend it. Then we go with UDP. So you can guess that most transportation is done on the TCP level because, obviously, we depend on the reliability of transfers. Right? And there's this word here called a checksum. The checksum, the way it's described here, checksum, it says it's a digit representing the sum of the correct digits in a piece of stored or transmitted digital data. So basically, it's used to check if there were any errors in your delivery, right? If we send this number of bits, we want to be sure that this number of bits, is calculated. It's kind of like the CRC, right? We saw that a couple of, I think, lectures behind. A CRC, it's a sort of a arithmetic kind of calculation on data to verify that the same number of digits that was transmitted is what gets there, right? So those are like two important, I guess, the most important concepts for you to be aware of when you talk about TCP and UDP. And of course, on page 248, it mentions the ports. It mentions the ports. let's see where it mentions the ports here. On page 248. Okay, this is a Internet World Layer Protocol. Okay, so right here, just a little bit more before we get to the ports. The ports are on page 248. It says the transport layer header provides the information needed to determine the application to which the received data is sent. So on page 248, if you go down to the topic of identifying source and destination applications, that is going to be right here. Where's it? Just want to be sure. We got this already. We got this part. Okay, right here. Yep, on this page. So it says, you see, under that header, identifying source and destination applications, it says the second paragraph there. The transport layer header provides the information needed to determine the application to which the received data is sent. TCP and UDP use a port number to specify the source and destination application layer protocols. So compared to an envelope, that's how you know the specific address of where that information should be delivered, sent and delivered. Right? It goes to an application on your computer or on the computer of the receiver. It might be an email communication that you're having, FTP communication, DHCP, POP, SMTP with email, DNS, whatever the communication is, there is an address that is attached to it on every system. So from your port 80 to the other port 80 on the other computer, right? That's how communication happens. The computers have to have the addresses. It has to have the IP address, the MAC address, the port number. That is how you get stuff there, you know, just like regular mail. Page 249. All right, so page 249, it tells us what we just looked at, that search we did online about the well-known ports. So on page 249, in that table, table 5.3, FTP, SSH, Telnet, SMTP, you have about 10 or 15 well-known ports. Well, you want to look at that page because you're going to need that information when you're doing your assignments and the midterm. It's going to ask you for some port numbers, which you should be familiar with. On page 250, I'm pointing out the pages in the book because it will help you when you're looking at this PowerPoints to know where they are at. So page 250 mentions the reliable transport layer. That's where we are on right now. The reliable transport layer establishes a connection when the data is large, right? It says when your data is large, it has to break down the data. Now let me show you a kind of an analogy with that, with the data. So I don't know if you guys have done puzzles in the past or recently, right? When you're dealing with puzzle pieces, where you have a lot of puzzles or a lot of puzzle pieces, right? So let's see if we can get through this quickly because we got a lot of stuff I just want to get through. Cole, are you there?
Yeah, I'm here.
Okay, Cole, have you done puzzles recently in the last 10 years?
Oh, maybe 20 years ago, I guess.
Okay, well, all we do is Mario and Nintendo and all that crazy stuff, right? Yeah?
Yeah.
Okay. So, but imagine this, right? If you pick up a puzzle piece, Core, and you flip it around, what's written on the back side of it?
It's just a blank side.
Just blank. Okay. Now imagine this. Would it be easier if the guys who make these puzzles numbered every single piece? 1, 2, 3, right up to 1,000. Will it kind of be easier?
Yeah.
It probably will be easier, right? Because you just have to look at, just look for the numbers and try to, attach the numbers, if that makes some sense. Now, when we talk about the transport layer on page 250, there's a concept called flow control. Flow control. We see that here. Okay, right here on this page. Flow control, right? It says flow control prevents a destination from being overwhelmed by data. So what happens is it has to segment the data. It says TCP breaks the data into smaller segments. It says each segment is labeled with a sequence number so that if the segments arrive out of order, they can be reassembled in the same order. So Dennis, sorry, not Dennis, Core. So here's what that means in a sense. Imagine that you have your complete puzzle board, right? And now you kind of, when the data is sent out, it might be too big to go as one piece. So you've got to just scatter all the data and get them to the destination somehow. But when it gets to the destination, because of what we call the sequence numbers, you're able to, just like a puzzle, reassemble all the data. Cool, how's that sound?
So good to me. Oh.
So that's kind of like, the data has to be broken up into many pieces, but because each piece is sort of has a sequence number, like it says here, right? Each piece or each segment has a sequence number. Even though it goes out of order, when it gets to the destination, it can be reassembled. Reassembled. All right? Reassembled. And you can understand that by looking at puzzles, even if you haven't done one in the last 20 years. Right? So flow control on page 251, that's what we see here on this slide. Flow control. It's a very important concept. If data is too huge, right? There might be just too much of a delay in getting it across, right? The whole system can become overwhelmed, right? He says overwhelmed right here. So we have to break it down into manageable pieces so we can properly transfer it to where it's supposed to go. And when it gets there, it gets reassembled. Reassembled. Sometimes you might buy furniture, or your parents might buy furniture, right? Let me go to, let's go back to Edwin.
Yeah.
Edwin, are you there?
Yeah.
Have you ever, maybe yourself or your parents or somebody you know, bought a large piece of furniture, and when it gets home, you have to break open the box and now start trying to assemble it, right? You get some little tools and put everything together.
Yeah, there's like a manual that comes with it.
Hopefully, right? There's a manual, right? Hopefully. Where's Edwin? Disappeared?
Yeah, I'm here.
All right, so what happens with the manual? What do you do with the manual?
You just follow the instructions to assemble all the pieces correctly.
All right, so, but why do they need to break it up into little pieces?
So it's easy to ship.
Easy to ship, exactly. That's how data is. Easier to ship, easier to send to you, right, in little pieces. But when it gets back there, unlike Edwin having to reassemble yourself, well, all those protocols, that's their job, to help you reassemble the data. So when that email comes to you, it's a complete email. It's not broken up into many, all the words are scattered all around the place. No, it's assembled correctly. That's referred to as flow control. Right here on this slide and on page 251. All right, let's look at the next protocol, your inter-network protocol. That is, go back all the way here. Yeah, that's going to be the protocol on the network layer. In the OSI model, it's on the network layer. That's what you have right here on the third layer, so to speak. The third layer here and the third layer here. Your inter-network protocol. So that's on page 252. So a few, I guess, tasks that have to be done on the inter-network layer defines and verifies the IP address. Right? Defines and verifies the IP address. Now let's look at an IP address here. I got to show you guys this. So here's an IP address, for example, 10.121.32.6. Okay, so I need you guys to be awake. Anthony, this part of the IP address, right? You see, all these different pieces of this IP address, it means something. So let's start from the top. The first two, so you see that they're separated by periods, by dots, right? The first two refer to what, Anthony? Do you know the first two refer to what?
The host, I think.
The host. Okay. So the first two, so let's say we go back to UMB, right? .edu, for example. All right. The first two there refers to the network, basically to the domain.
Okay, yeah.
Anthony, are you with me? The first two refers to the network.
Yep.
So in this case, this will, and when you say the network, it's a physical location, not something in the cloud, a physical location, just like we've looked up IP addresses to see where the IP address points us to. So it's a physical place that it points to. So it points to the domain. How about the next part? How about the next part here? Anthony?
Yeah.
The 32 refers to what? A subnet.
Okay.
What's a subnet? Well, you have think about it as a pizza. You got to slice your pizza up into manageable pieces, right?
Yeah.
You don't just grab the whole pizza and just stuff it in your mouth. You got to, many times you got to slice it up. So in a large network, you might want to subnet your network into sections. So you might have a section that is for maybe the IT department, maybe you have the HR department, maybe you have the administration, maybe you have the library, right? You have different subnets so they can be managed and easily managed. That's the whole idea. So that's the subnet. So the first two, and you're going to see these questions in your assignments and exam. The first two refers to the domain, the network, right? The next, this part here, so first two, so this is first two, right? This is the third. Okay, how about the last part, the 6? Brooke, are you there? What does the 6, what does that point to?
Is that the device on the network?
Device. Also, we call it what? We also call it the host. The device or the host. So your computer, so if you have, your coworkers and there are 20 of you in the office, right? You're going to have, the IP addresses might sound something like this. 7, then you have another IP address that is 8. And this represents what? If you saw this, Brooke, if you saw this in an assignment, it says, how many people, this 4 addresses tell you that there are 32 computers in this company. Is that true or false?
That would be false.
That would be false because the 32 only refers to the subnet. But the 6, this is 1 computer, 2, 3, 4. individual computers. Every individual computer has an IP address. So 6, 7, 8, 9. So they're in the same network, same network. Now, if you had, how about if you had something like this, Brooke? If you had something like that, 33. What would this mean?
Would that mean that there's 3 on the network then?
No, there are 4 on the network, but this guy is in a different subnet. So this guy here might be, who knows, in accounting, and all the others are in the library. It's a different subnet. The subnet, you can think about it as a department in the whole company, right? Or you can think about it as a, you know, as an institution at UMB. Like, we want to keep everything separate so we can manage them easily. And they all refer to computers. I mean, you have thousands of computers at UMass Boston, right? You want to be able to manage it into like groups. Okay, we're going to have 250 computers here, 250 computers there, 250 here, 250 here, in a manageable way. So that's why we create subnets, right? So if you saw this picture here, right, there's only one, there's an odd one out, and that is this guy here is on a subnet, a different subnet. So 32, 32, so they all have the same host, same host, same host, same host, but one is on a different subnet, but they're all unique computers. So important for you guys to know that you might have to go over this video because we're almost out of time after over this lecture. All right. So that's one of the important jobs of the internet layer protocol. Okay. All right. Let's see what else. Well, we're almost to the end of the book. We have just a couple more pages. So let me see if I can just fly through that in the next 3 minutes. You guys got to read. You got to read this chapters and finish up the PowerPoint. But we're actually literally at the end of it. So you verify. So that's the IP address. Very important for you to understand how the IP addresses are set up. Okay, and it says it right there on the Internet Network Protocols. Okay, of course we know about MAC addresses, so that's something we talked about before. The MAC addresses are part of the addresses that are used by your IP to get your messages across to you. All right, let's see what else we got there. Well, the last couple of things we should look at is, so here are the IP addresses, right? Right now, IPv4 is like the most common. IPv6 will come, you know, it's getting more and more common. Well, why is that? That is because of a concept. We're going to look at that in chapter 6 that tells us that IP addresses, IPv4's version 4, we're running out of IP addresses. So IPv6 has more to offer than IPv4. So we're going to look at that in chapter 6. Okay, we're talking about MAC addresses and IP addresses, so we can just skip that part. All right, so encryption. Okay, let me give you guys this video here. I'm just going to put in the chat. Because you have questions coming out of this video, so I'm going to put it there so you guys can take a look at it. Where's the chat? Right here. All right, so take a look at that video there. It's something like, it covers some of the things we've discussed already. It's about the Osi model explained in a kind of a real world sense, okay? All right, so I just put that there for you guys. Save that and take a look at it later. All right, so the last thing you want to look about, it's right there in the book. It's on page 263, and that just covers the network access layer that we didn't really talk about today, but we've talked about it before. That's where you're going to find all the information about this part here, the very first part, this part here, right? The bottom part is where you find your Ethernet cables and fiber optic and wireless. That's at the very last layer there, the network access, the physical layer. All right. So go over this lecture again. A lot of things we've discussed already, and the PowerPoint are going to be helpful for you when you do your assignment and especially your midterm. So let's talk about the midterm quickly. The midterm is it's going to be in exam mode. So when I say exam mode, well, I'm going to stop the recording right now. Let me just stop the recording and then